We're now going to use a given binomial population in order to solve for probabilities that a sample drawn from that population would be between certain values of p hat. So in this case, we're taking a sample of size 66 from a population with p equals 0.4. So the z-score formula is really z equals whatever the p hat is from my examples. So really the x here is the p hat minus mu sub p hat over sigma sub p hat, which is really p 1 minus p over n all under the square root. So in the case of this 0.3, p hat is 0.3 minus the given mu sub p hat, which is 0.4. Remember that what you're doing underneath the square root here in the z formula comes from p, not from p hat. So down here I should be using the 0.4 that's the population value, not the 0.3 that I'm using to inspect. So down here it's 0.4, 1 minus 0.4 over n, which was 66. At the same time, I'm going to need to calculate a z-score for 0.35. So that's going to be 0.35 minus 0.4 over the root of 0.4, 1 minus 0.4 over 66. When I do the first one, parentheses 0.3 minus 0.4, and parentheses divided by the root of parentheses 0.4 and parentheses new parentheses 1 minus 0.4 and parentheses divided by 66. I get all that to be negative 1.66 as a z-score. When I now do it for 0.35, I get that z-score to be negative 0.83. Now that I've converted them to z-scores, I can find probabilities using my table. For negative 1.66, it's negative 1.6 as a row over to the 0.06. I get 0.0485. P equals 0.0485. When I do it for negative 0.83, I go to the negative 0.8 row over to the 0.03, and I get 0.2033. P equals 0.2033. For a between question like this, we take larger p-value minus smaller p-value. So the overall answer is going to be 0.2033 minus 0.0485. When I put that into my calculator, 0.2033 minus 0.0485. That's how I get my final answer of 0.1548. Next one's slightly easier because I only have one number that I have to put in, the 0.42. So I set up z equals 0.42 minus 0.4 over the root of 0.4, 1 minus 0.4 over 66. When I put this into my calculator, it gives me a z-score of 0.33. I look up that 0.33 on the positive side of my table. 0.33 points me to a p-value of 0.6293. In this case, since it's a less than question, I can just use exact table value, and the answer is 0.6293. For the final part here, when I'm doing p hat is greater than 0.51, again, I need to find a z-score for 0.51. So I do 0.51 minus 0.4 over the root of 0.4, 1 minus 0.4 over n, which is 66. So I put that in, put in 0.51, and I get an answer of 1.82. That 1.82 in my table traces me to a p-value of 0.9656. I could stop there if it was a less than question. Because it's a greater than question, I have to do 1 minus. that 0.9656, which gives me 0.0344.